technical director of Fenestration Canada, who's by no means an unknown name in the industry. So many of you may know Al from his previous role at RDH as a senior fenestration specialist. So recently, Al has assumed a new role at Fenestration Canada, where he's providing support and education to the fenestration industry at large. He's also been a member of the CSA Committee on Fenestration in Canada. And he also runs a very interesting weblog that I recommend everybody to check. So without further ado, I'm going to pass it on to Al. Al, please take it away.
Thanks, Sper. Nice to be with you and to share this information with all the folks on the line today. So our topic today is performance testing and labeling for windows, doors, and skylights. And this is a public service presentation from Fenestration Canada. We offer this educational presentation as a public service to inform building officials, builders, and the general public about the performance testing and labeling requirements for window, door, and skylight products contained in the 2018 BC Building Code and 2019 Vancouver Building Bylaw. This presentation doesn't address labeling or marking requirements that apply to the glass used in these products. These are markings that identify compliance with safety glass or insulating glass testing requirements. While every effort has been made to summarize information drawn from the code and the standards referenced in the code, we can't guarantee that this information is, free from errors and omissions. So certainly respect the jurisdiction of local authorities to make final determinations on understanding and interpreting the code. What problems does this presentation cover? We can see that there are two broad categories of fenestration products defined in the BC Building Code and the Vancouver Building Bylaw in subsection 592. One group of products is what we call window, door, and skylight products. And these are products that are in the scope of the NAFS standard. The standard with the longest name of any standard in the building code, AMA WDMA CSA 102 IS2 A440 11. We just call it NAFS 2011 or NAFS 11, the North American Fenestration Standard. The reason it has such a long name is because it harmonized the Canadian CSA standard with two American standards to be a standard that covered the requirements for all of North America. And this was a great achievement. It was very beneficial to the industry to do this, but we ended up with a very convoluted standard name. So basically, from now on, we'll just call this NAFS in our presentation today. The code also recognizes another category of products, and that would be other glazed products. And these are products that are outside the scope of the NAFS standard. And it includes curtain wall, window wall, storefront, and glazed architectural structures. So this NAFS standard applies definitely to the window, door, and skylight products we normally see in small buildings. And it does apply to, windows, sliding doors, and things in large buildings. But when it comes to the commercial glazing systems, those are outside the scope of this standard. So the presentation we're going to have today applies only to the window, door, and skylight products that are in the scope of the NAFS standard. So there are two categories of performance ratings that we're going to talk about. And windows, doors, and skylights are integral components of the building enclosure of walls and roofs. And the code requires windows, doors, and skylights to maintain environmental separation between the exterior environment and conditioned indoor spaces. With respect to the exterior environment, the job of the building enclosure, which includes windows, doors, and skylights, is to resist wind, rain, and air infiltration. And we talk about these as structural air-water performance ratings. With respect to the interior environment, we're concerned about the ability of the building enclosure to preserve heat, to resist the heat loss through the enclosure, through windows and doors. And here we talk about energy performance ratings. So both structural air water ratings and energy ratings are reported on product labels. and are tested to specific standards in the code. So in part one, we're going to talk about structural air-water performance and testing requirements. And in part two, we're going to talk about energy performance. So when we think about it, the enclosure of the building here is in part five. The main thing that the part five of the code is concerned with is that the enclosure of the building is protecting us from air leakage. Resistance to air leakage is a property that the enclosure must have, and windows, doors, and skylights as elements of the enclosure must also have resistance to air leakage. Resistance to water penetration due to rain and melting snow is another top item that Part 5 is concerned with, because both infiltrating air and infiltrating water, if they penetrate the building enclosure, if they penetrate to the interior of the building, can cause damage to the enclosure and could render the building to become inoperable. And so the Part 5 of the code wants to ensure that these properties are adequate to the environment that the building is in. And then, of course, we come to wind loads and snow loads, which exert physical pressures on the window or skylight system. And so windows, doors, and skylights also need to have structural resistance to the wind and snow loads that are applied to them. So together we can think of these Part 5 properties of windows as structural air and water performance requirements. So these properties are tested and labeled to two standards in the building code. First one we've already mentioned, the NAFS 11 standard. And the second one is the Canadian supplement to NAFS 11, CSA A440S117. And we needed the Canadian supplement because whereas the NAFS standard contains requirements that are applied to all of North America and all of the different things that can be tested, the Canadian supplement tells us which properties we want to label, and it has some additional testing requirements, and it also provides us with the methodology for determining what level of performance do I need at a building in any particular location in Canada, anywhere in BC. And with respect to tall buildings, when I have windows and doors in taller, larger buildings, we're going to have stronger wind effects on that building as you go higher up the building. So this methodology in the Canadian supplement to NAFS allows us to determine what those wind pressures and driving range wind pressures are for windows, doors, and skylights. So when we look at the properties that are tested under the NAFS standard, the first one is called performance class. And in the standard, it's a very important classification system. This is something we borrowed from the Americans because this methodology has been in place for a long time in the US, but it was new to us when the NAFS standard came into the code in Canada. So the standard requires products to be classified according to 4 general load resistance categories, from low to high. So the weakest level of load resistance, you might say, is R. And then LC, CW, and AW are higher classifications. Now, there is no minimum code value for performance class. The class is, any of these classes is acceptable under the code. And when we say that it's a general load resistance classification, that's because there isn't any way to say, oh, for this building, you need this class. This is a property that is actually there for architects to use when they specify windows and doors. They may wish to choose products from a different class for their own reasons. But as far as the code is concerned, other properties are more important, such as the performance grade. This is a structural performance calculation classification that is actually based on the tested structural wind load resistance, and in the case of skylights, snow load resistance properties of the product. A second related characteristic is the tested design pressure. So whereas the performance grade is a classification that goes from PG15 to PG100, the design pressure is the actual tested design pressure in pascals measuring the wind load resistance. The water penetration resistance is the other property that's of concern, and this is the resistance to wind-driven rain measured in pascals. When the products are put into a test chamber at the lab, they're spraying water on one side of the product, they're creating a negative pressure on the inside of the product, and basically they test until the product fails to get what is the highest level of resistance to that wind-driven rain. And the last tested property is air infiltration and exfiltration level. There are 3 available ratings in the code: fixed, A2, and A3. Now, the fixed rating applies to all non-operable products. So a window that doesn't open, if you had such a thing as a door that doesn't open, it doesn't make sense. But if it's a non-operable product, it requires to have the fixed level of air leakage resistance, which is more airtight than an operable product. Operable products are allowed to have a higher level of air leakage at A2 or A3. So the minimum level of performance for operable products is A2. The A3 level is actually better. It's more airtight, but the code allows products to have a level of A2. When we look at properties regulated by the code, the only properties of the NAF standard that the code cares about are the ones in the red box: performance grade, design pressure, water penetration, test pressure, and the air infiltration exfiltration level. The minimum code values are described here. For Part 9 buildings up to 10 meters in height, we can use the table C5 in Division B of the building code. And we'll look at this table in a moment. For all other buildings, in other words, Part 9 buildings greater in height than 10 meters or buildings outside of Part 9, we can use the CSA A440 methodology. And we're going to talk about that in this presentation as well. So when it comes to product labeling, the standard that governs the high-level requirements is CSA A440 S1. It requires manufacturers to label products with these structural air-water performance levels. The nationally accepted label format, what actually in more detail should be contained on the label and acceptable labeling formats, are described in the NAF's labeling guidelines for Canada, which are available from Fenestration Canada. These guidelines were developed by the industry in a way that would satisfy code requirements and also provide additional information to make labels equivalent in terms of the information provided to the kind of information you would have on a certified product label. In addition to the requirements in CSA A440 S1, the national guidelines require the manufacturer and the product line to be identified on the label, as well as the specific year version of the standards the products have been tested to. So here are some examples of structural air-water performance labels. You'll notice that they don't necessarily look the same. And in the NAF's labeling guidelines, you see more examples of varieties of labels. But all of them must have certain characteristics to be complete. For example, each one of these labels summarizes the performance properties that are tested in the NAF standard, such as the performance class. It may, in some cases, it may use the terminology class R. In other cases, it might just say LC, which is the LC class. So there are abbreviated, shorter versions you can use in labels when there isn't the space for longer designations. But always you have the class, the performance grade, the size tested, and optionally the operating type of the window. So in this label here, we identify it as a hung window. In the other two labels, that is optional. It's not required. The design pressure, the water test pressure, and the Canadian air infiltration exfiltration level. So these properties must appear in each one of these labels. The other thing we want to see on the label is the version of the standard that these properties were tested to. And finally, we want to identify the manufacturer and a description of the product line. Now, the two labels on the left are just describing the structural air-water performance. We typically call these the NAFS labels because they are tested to the NAFS standard. But sometimes manufacturers want to combine this NAFS performance information with their energy performance information on a single label. And so the label on the right gives you an example where it serves both functions, the energy performance label and also the NAFS labeling. So labels can have multiple ratings on them, but here we're focusing on the structural air-water performance labels. This slide summarizes the types of labels that you are likely to see to report your structural air-water performance labels. And we can make this slide available to you guys if you want for reference purposes, just as a pictorial guide to help builders and other people in the in the municipal department recognize which labels do what. I think it's helpful also not just to know about labels and what I'm telling you. I think it's helpful for us to know a little bit about the language of the code itself in Part 9. Windows, doors, and skylights are described in Section 9.7, and the matters we're talking about today are in subsection 974, which is titled Design and Construction. And Article 9741 tells us that except as provided by Sentence 2, windows, doors, and skylights and their components shall be designed and constructed in accordance with Article 9742. And Article 9742 appears immediately below. It's titled Standards, and it identifies both the NAFS standard and the Canadian supplement to NAFS. The code also has an OR here, and it says OR Part 5. And the Part 5 option refers to Article 5922, which isn't explicitly mentioned here, but it's the only part of Part 5 which specifically deals with fenestration products, including windows, doors, and skylights. We won't talk about it here, but the code does entertain the possibility that there are times when using that Part 5 option makes sense. If we look a little bit further down the page from standards, the code tells us a little bit about the limits on limited water doors. Limited water doors are doors that have less water penetration resistance than they would require for their performance grade. So because they have limited water penetration resistance, the code puts some limits around where limited water doors can be used. For example, a door that separates a dwelling unit from an unconditioned storage garage or a carport. So if the door is protected from rain, it doesn't need to have that full water penetration rating. If the door is designed to comply with the requirements for an accessible entrance door, which are spelled out here, accessible entrance doors are allowed to be exempted from the water penetration requirement, not because the code doesn't care, simply because those doors, because of their design, are not able to provide the required level of water performance. It's mainly that low profile door sill, which does not able to have a level of water penetration resistance that would be optimal for a door that is providing you protection from the exterior environment. And the third exemption is doors that are not required to have a flashing installed by Sentence 927.383. So if the door does not require a head flashing in Part 9, then that door may have a limited water rating. So limited water doors, here's what the standard says about them. They have a water penetration resistance that is lower than is required for the performance grade. So a door that has a performance grade, a particular performance grade, may require a water penetration resistance of 220 pascals, but maybe the door only achieved 140 pascals in the test. So it has some water penetration resistance, but not as much as it would be required for its performance grade. Because of that, it may or may not have enough water penetration resistance for the building location. And so that's why the code allows them to be used only where the risk of water penetration is low, such as doors that do not need a head flashing, a door that provides access from a house to an unconditioned garage or carport, or a door that it complies with the accessibility requirements of sentence 97422. Because of their low profile sills, these doors cannot completely keep out the water when it's being driven by wind. And so ideally, other measures should be taken to protect the building from driving rain in those settings. It could be possible to install an overhead canopy over the door. It might be possible to, when designing a building, it might be a way of recessing that doorway from the exterior face of the wall. Measures should be taken to ensure that the floor finishes on the inside are not ones that would deteriorate from occasional wetting or that would lead to structural damage to the building. So ideally, you don't want to compromise the water performance of the building, but the code recognizes that accessibility in this case is more important than the water penetration performance of that door. And so it allows these doors to be exempted from that requirement. The next thing we'll talk about is the required level of structural air water performance. So how do we know what level of performance we need? We're building, in this case, your builders in Richmond, building officials in Richmond. The code lets us use table C5 if the buildings are up to 10 meters in height. And in Article 9743, for the purposes of compliance with the standard referenced in 97421B, which is the NAF standard and the Canadian supplement, windows and doors and their components in a building of no more than 10 meters in height, measured from grade, may conform to the design pressure, performance grade, and water resistance values in Table C5 of Appendix C instead of the values calculated in the CSA A440S1 standard. So buildings up to 10 meters in height can rely on Table C5. Taller buildings or buildings outside of Part 9 would be calculated using CSA A440S1, the Canadian supplement to NAFs. So this is what Table C5 looks like. And, it's easier to see the headings of the table if we're at the top of the table. So we'll use Abbotsford as an example. Basically, all you have to do is identify your location in British Columbia. If you're in Abbotsford, your required performance ratings, you have a design pressure of 960, a minimum performance grade of PG20, and a water resistance test pressure of 180. So in the example I gave of a door that may have had only a water penetration resistance of 140, you could have used that door in 100 Mile House. Even though it was a limited water door, it would have had enough water penetration resistance to satisfy 100 Mile House. It does not have enough water penetration resistance for Richmond. And so this is where the limited water restrictions would kick in to that limited water door. The A440S1 standard has methods and tables for determining the required level of performance. But Fenestration Canada recognized that not all building officials have access to that standard. Certainly not all builders are going to be, having access to using this national standard and figuring out how to do those calculations. So years ago, when the NAF standard came into the code, we put online a fenestration performance calculator. You can access this calculator online by searching for the term Fenestration Performance Calculator 2017 in any browser, or using the link in the presentation here. When you do a search to the browser, you'll notice that you might have a couple of hits because there's an older version of the calculator and a newer one. So be sure to use the calculator for February 2017. That's the one that belongs with NAFS 11 and CSA A440 S117, the version of NAFS that's in the code today. The old calculator uses an older version of that calculation, which has been superseded by the new one. This is what the calculator looks like when you get to it. And it's important to note that you can access either the new or the older version here, depending which button. If you clicked this button, for example, you might end up in the July 13 calculator. So before using it, check to make sure that you are using the February 17 calculator that goes with the CSA that's based on A440S117, as shown here in the blue box. And these are calculations based on NAFS 11 and the Canadian supplement to NAFS 11. As we look at the bottom of the calculator, we notice that there are some definitions there regarding terrain. And it's important to understand those definitions so you make the right choice when you come to the terrain option in the calculator. Let's take a look at those definitions right now because it's important to be clear about what they are. There are two definitions, open terrain and rough terrain. Open terrain is defined as level terrain with only scattered buildings, trees, or other obstructions. It is also open water or shorelines. So open terrain looks like the prairie. There is nothing on the prairie that will protect you from wind. You've got scattered trees, scattered vegetation. If you're beside a lake, if you're beside the ocean, there's nothing there that will reduce the full intensity of the wind load. Rough terrain is defined as suburban, urban, or wooded terrain extending upwind from the building uninterrupted for at least 1 kilometer or 20 times the building height. If for Part 9 buildings, it's always going to be the 1 kilometer limit that applies. So rough terrain is what you see in the lower part of this photograph, the other side of the highway from the prairie. Suburban, urban development. It's just that all of the buildings in this photograph are still in open terrain because they're just too close to open terrain for the wind to be any less intense in this area. According to the definition, you need to be at least 1 kilometer away from this road to actually be in rough terrain. So these are the terrain categories that we have in the code, and it's important to note which terrain you are in when you're using the calculator. So now that we know that, let's walk through the inputs of the calculator and the results that it gives us. You start off here with choosing the province you're in. You can choose your city, and you choose your building type, Part 9 or other. It's very important to make the correct choice here because different calculations are employed for larger buildings than for smaller buildings. The product height starts at 10 meters. This calculator is concerned about the performance level at the height that the product is installed. So if you have a 10-story building, the windows at the upper part of the building are going to be subjected to higher wind and driving rain wind pressures than the ones at the lower part of the building. So this is where we choose the product height. Often we just use the height of the building for this purpose. And in Canada, we measure wind loads at 10 meters, so all values start at 10, and then they are increased as the building height is higher. The next choice we make is the terrain. So in this case, we've chosen rough terrain for the calculation. So we've chosen a city, Penticton. We've chosen a building that's 10 meters or less, and we've chosen rough terrain. The next choice that you make is the performance class. And here it's very important if you want to know what is the driving rain wind pressure, what is the wind pressure at the building location, choose class R. If you choose a higher class, the calculator will choose a higher level of performance based on the minimum of the performance class. So you're going to get higher levels than the environment requires. These options are helpful for architects when they want to determine what level of performance should be specified when they choose a higher performance class. For knowing what level you need at the under the building code at the building location for the environment the building is in, choose class R. And now the calculator gives your outputs. In this case, in Penticton, you're looking at a performance grade of 15. Clearly not very high wind pressures there in the rough terrain part of the city. Your minimum positive and negative tested design pressure for the products. Your minimum water penetration resistance test pressure, it's very low in Penticton, be significantly higher here in Richmond. But these are now the outputs of the calculator, which tell you the performance level you need at the building location. Now, the helpful part of this calculator is that at the bottom of the screen, you have a field where you can type your notes to record why you're doing this calculation. Are you a building official wanting to record it? Are you a manufacturer wanting to obtain windows with a certain level of performance from your supplier, and you want to make sure that, and that's why you've done this calculation? So it's just handy that you can type in here when you did your calculation or why, for what reason, and you can print it as a PDF file and keep it for your records. So let's review the structural air-water topics we've talked about today. Windows, doors, and skylights are integral parts of the building envelope that provide environmental separation between the exterior climate and the building interior. The BC Building Code and the Vancouver Building Bylaw have a table C5, and also we have the Canadian supplement to NAFS, which we can use to determine the required performance grade, design pressure, and water test pressure for buildings under 10 meters. The Canadian supplement we can use for buildings taller than 10 meters. I'll have to fix that. And these are the properties that are of interest to the code. Structural air-water performance testing is required to determine that these products can resist the environmental loads at any given building location. So it's the manufacturer's job to test their products in the lab to determine what level of performance they can achieve. Product labels report the tested product performance ratings for code compliance purposes. There is a Part 5 option that can be used when testing is not possible or practical. And I think here it's worth assigning some required reading. I think it's really always helpful for code users to understand some basic parts of the code that apply to what they do. And now, since earlier this year, the province and in fact all across Canada, governments have made building codes available to the public at no cost. You can access the BC Building Code and the Vancouver Bylaw from this link. And when you start browsing the code sections, as soon as you hit a section such as 9.7 or the notes to Part 9, it'll appear as a PDF file that you can download or print. So I think it's really helpful to actually, from time to time, read the code to see what it has to say than just listening to what people tell you. So that ends that part of our presentation. We're now into a shorter part. We're going to talk about energy performance and energy performance labeling. And here we're concerned with what labels are required to identify the performance of windows, doors, and skylights with respect to the interior environment. And here the job of the building enclosure is not to keep the outside out, it's to keep the heat we generate to heat our buildings inside. We want to minimize how much heat escapes through our windows, doors, and skylights. And if we ever wonder how much heat is going out that way, just get close to your window, especially your older windows, and you'll notice that in older windows, you're much less comfortable beside the window than the wall. You can feel the difference as your skin is close to the product, and you can tell that heat is being lost here. With higher performance products, especially triple glazed windows with several low E coatings, you can feel as comfortable beside the window as you do beside the wall. So in British Columbia, energy performance is regulated on the basis of U value or U factor, which is a measure of heat loss in winter. And because you're measuring the heat escaping out from the windows, lower U values are better because it means less heat is escaping. The energy rating that is used in the Energy Star program is not used in British Columbia for code compliance. It has not been used historically, although I noticed that the 2018 building code online contains tables from the national code which do show energy ratings, but historically British Columbia has not used energy ratings for code compliance of windows. U values are evaluated and labeled to either one of two standards. The CSA A440.2 standard, called Fenestration Energy Performance. Alternatively, the code also accepts U values determined to the NFRC 100 standard, which is called Determining Fenestration Product U Factors. Many Canadian manufacturers choose to certify their energy performance through NFRC, especially if they're selling products in both Canada and the United States, because the NFRC methods are recognized in both countries. The CSA methods are recognized in Canada only. Different codes regulate U values differently here in British Columbia. The Vancouver Building Bylaw, in the 2019 Building Bylaw, puts the prescriptive U values in Article 10.227. The BC Building Code, the base code U values are in Article 936.27. For step code projects, I understand that the U value and solar heat gain values, when you're actually working with a energy modeler to model the energy performance of the whole building, the builder and energy modeler make decisions about which windows and doors they're going to use, and they will essentially come up with values that make the building work to reach a step code value, and they may come to a fenestration manufacturer and saying, I need this U value and this solar heat gain coefficient for my windows. So under the step code, when there's a performance model for the building, the U values are not coming straight out of the code. They're actually a result of the energy model that's developed for that building. There's also a BC Energy Efficiency Standards Regulation, and Section 27 stipulates the maximum allowable U values. The regulation is a regulation that applies to window and door manufacturers. They're not allowed to sell products that have U values higher than are permitted under the regulation. At this time, the Energy Efficiency Standard Regulation U values are the same as those of the building code, and generally they do not, they're never more aggressive than those in the building code. But the Energy Efficiency Standard Regulation is important for another reason, and that is because it requires all window, door, and skylight products sold in BC to have certified U value labels. So whereas the building code allows manufacturers to report their NAFS ratings, their structural air and water ratings, the manufacturers can self-report the ratings they've obtained in their lab test reports. When it comes to energy performance, the Energy Efficiency Standards Regulation says, no, you can't self-label your energy performance. You have to work with a certification organization and label in accordance with the requirements of the certification organization. The Energy Efficiency Standards Regulation recognizes certification organizations accredited by both the Standards of Council of Canada and NFRC. Certified products must have two labels: a removable temporary label that reports the manufacturer's identity and U value, and a permanent label that identifies the manufacturer and the certification program, which remains visible after the products are installed. In the case of operable products, you can often look for that permanent label when you open the product and look somewhere inside the frame or on the edge of the sash. On fixed products that can't open, sometimes the label is hidden underneath a glazing bead, just because homeowners don't want to see these product labels to be visible on their products. Sometimes the permanent marking is actually etched into the glass. So there are different acceptable ways of indicating the permanent marking. It depends on the certification program's rules and which option a manufacturer has selected for that purpose. And certification is important because it requires the manufacturer to comply with the certifier's quality management and labeling requirements. Essentially, the certification organization has copies of the manufacturer's tested performance data. They perform audits occasionally of the manufacturer to make sure the manufacturer is labeling correctly. And they also ensure that the manufacturer understands the labeling requirements, has quality management procedures in place in their operation to ensure that the right label gets put on the right product, so that the labels can be trusted. When a manufacturer is enrolled with a certification organization, and only then they are permitted to use, and in fact they're required to use the certifier's mark on their product labels. The following organizations are known to be accredited to certify window U values in Canada today. We have CSA, Intertek, QAI, LabTest, Keystone, and NFRC, National Fenestration Rating Council. Certification does provide a measure of assurance that the manufacturer's labels can be trusted, that there's another party that is actually involved in the labeling process. So here are some examples of energy performance labels. They may have different formats, although these days sometimes we're seeing more and more standardization of labeling, but some certifiers do allow their manufacturers to create formats that are different than the typical ones. So here's one type of label format. You'll notice that all of these labels do show a certification mark on them. The first label on the left here is reporting energy performance characteristics only. This one's a Canadian certifier. The second label is a typical NFRC certification label. The NFRC labeling requirements are very strict. Everyone uses the same label format under the NFRC system. Canadian certifiers may allow other formats to be used. Here's an Energy Star label, which has a pretty typical looking energy portion below it, and then on top has additional information indicating the product actually qualifies for the Energy Star designation. And the label on the right includes a NAFS label as well. Some manufacturers find it more convenient to print these labels in the factory and on-demand printing setups, where they can print the label, all the information that applies to the product on a single label, and that's permitted. So in this case, the label includes your NAFS ratings. And finally, when it comes to the U values, some organizations report both the metric U value and the inch-pound U values that are used in the United States. And when you see more than one U factor or U value on the label, you need to understand that in British Columbia, it's the metric U value that is the U value that we're using for code compliance. So this slide shows sample energy performance labels that with a graphic that again shows you what the context in which these labels apply. And I'll make these two slides available to you guys that you can use for your purposes to when you're communicating with builders or communicating with other parties about product labeling. So that ends the presentation portion, and I'll be happy to take questions from those online.
Thank you very much, Al. Thank you very much for the very informative presentation. And I would remind and encourage everybody to use the chat feature to send in your comments or questions. Before we get to those, I did have a couple questions for you myself, Al. And this is an issue that we have been dealing with in Richmond, and from what I hear from our colleagues in other jurisdictions, it is not very uncommon. So you talked about the energy efficiency standards regulation and how that's kind of an additional piece of legislation in BC on top of the code requirements. And I guess especially as as far as the energy performance requirements are concerned. Can you also talk about the actual procedure for labeling, and particularly, is it acceptable to have a product labeled on site at the building site, or should these labels be affixed by the manufacturer or the supplier?
They are not. It is not acceptable to apply products at the building site. The products are required to be applied at the point of manufacture of the product. And the reason for that is to make sure that the right products get applied in the place where the products are actually assembled, where the people, if they're doing their job, that's where they're supposed to be applied. If they're not applied there and somebody shows up with a roll of labels, how do you know that there's been any, that they've got the right roll of labels, that they're, it's just questionable. Why are you doing this now? It's your job to do this at the factory where it should be done. Certainly when you're under a certification organization, certification organizations do not allow labels to be applied anywhere other than the location where the manufacturing takes place, or another designated location that the certifier is aware of. For example, there might be a business that imports windows from the United States and has to apply a label with the Canadian U values or something like this. There might be some situation where the certification organization will allow the labeling to take place in another location, but it's a controlled location. It is not. It's not the job site. And so yes, that is very clear.
And a follow-up, if I may. So as building officials, for example, my building inspector colleagues who go out to the field. So if there is a product that doesn't have that removable label, the energy performance label, assuming that it's separate from the structural and water label. So if I go for inspection, I see a window that doesn't have that label, by the time I go for inspection, then what is the course of action that you suggest? Or thinking about the regulations, is that, do we have let's say the legal grounds for rejecting that installation, for rejecting that product because it didn't have the label affixed on it at the time of inspection?
So here's the situation. The energy efficiency standards regulation is a law, but it's outside of the building code. So on one hand, it's not your job as a building official to administer the energy efficiency standards regulation. However, the regulation is there to ensure that manufacturers understand how to label correctly and are labeling their products as required by law. So if windows show up at your job site without labels, they, by definition, they are not demonstrating their compliance in the expected fashion. And so you can't assume now that somebody shows up with a roll of labels that basically it's a matter of trust me, this is what my labels, we forgot to put them on. Well, it's your job to put them on where they're supposed to be put on. If they show up without labels, you cannot determine that they comply with the code. And at that point, somebody is saying, trust me, my windows comply with code. Well, should you trust somebody who has not taken the trouble to do their job properly and put the labels on where they're supposed to be put on by law? So even though it's not your job to enforce the law, do you trust somebody's word or promise over them having failed to do what they should have been doing under the law in British Columbia? So, I think that's the context in which to make your decision. I think it's very difficult then to be confident that the products comply with code when the company supplying the products has not done what it's supposed to do under a provincial law.
Okay, thank you. That's very clear. There's a follow-up question from Sarah, who's asking, is there a specific body who's tasked with regulating and enforcing the energy efficiency standards regulation, or is that just kind of vague still?
It's the Ministry of Energy, and the Ministry of Energy has at least one, if not several, inspectors whose job it is to, visit manufacturers periodically, and also to follow up on complaints, of manufacturers maybe who have been reported as not, supplying unlabeled products. So yes, it's possible to contact representatives of the Ministry of Energy. I can't tell you exactly who to contact, but if you wish to contact me later, I can provide you with contacts at the Ministry of Energy and Mines who actually administer the energy efficiency standards regulation.
Thank you. There was also a question from Derek about when the requirement for a visible label was brought into effect. And I'm not sure if that refers to the permanent marking or the removable, but if you can just briefly talk about when these regulations took effect.
The energy efficiency standards regulation took effect, I believe, in 2007. So it's been around for quite a while. It's been updated multiple times since then. There may not have been enough education on it. There was a time when it wasn't being enforced very rigorously, and I think people started to get careless. But it's been a provincial regulation for a long time. It's not something that just happened, 6 months ago.
I see. I also had, again, another question, on the energy aspect of things. So you talked about the U value and how it is the main characteristic as far as these regulations are concerned. But we also know there is another important parameter, namely the solar heat gain coefficient. And I understand this is now kind of going beyond the original scope of this talk. So it's not strictly talking about the, labeling requirements. But from a design perspective, can you comment on the importance of the solar heat gain coefficient? And I guess a more practical question is, let's say I'm an energy modeler, and I know that there are many energy advisors on the call. So if I'm an energy modeler and I'm working with my design team to come up with the right combination or the desirable combination of U value and solar heat gain coefficients, can you just provide some general guidelines as to first what things to consider? Is it reasonable to assume the same solar heat gain coefficient for all facades, for north facing, west facing, south facing? And then also, is it realistic to assume any combination of U value and solar heat gain coefficient, for example, U value of 1.4 and then a solar heat gain coefficient of 0.4, only to satisfy the modeling or the modeling outcomes that are desirable or required?
This is a very good question and a very important question. There's several aspects to it. I'll tackle the last item first. You can't, as a specifier, and so if the energy modeler is making, and together with the builder, are making a decision, okay, we're going to use windows with this U value, this solar heat gain coefficient, you can't just choose any numbers you want because those products may not exist. So you have to understand that the more low E coatings you have in a piece of glass to lower the U value, you are reducing the solar heat gain coefficient as well. So, the lowest U value coating that you have is going to have a lower solar heat gain coefficient than a higher U value low E coating. So typically, like a double glazed window with a high solar coating gives you lots of solar heat gain, but it doesn't have the lower U value. As you start looking for a product with lower U value, the available solar heat gains are lower. So you have to work with the manufacturer, look at manufacturer's literature or information they can provide you, what's available. Because you might want a window with a U factor of 1.4, for example. And you may not be able to get that with a solar heat gain of as high as 0.40% or 0.40. You might be limited to 0.32 or 0.28. And the solar heat gain coefficient is evaluated at the standard size of the window. So even if you have the same glass, a fixed window is evaluated at a larger size, operable window at a smaller size, and the operable window also has more frame and less glass. So you can take 3 different product types, a fixed window, a casement window, and a sliding window, all with the same glass from the same company, and each one will have a different solar heat gain characteristic, even with the same glass. And the U values will also be different slightly because you're evaluating the products at different sizes. So it's very easy when you're doing an energy model to say, okay, if every window has this U value and this solar heat gain coefficient, this works. But the reality is you're not going to find a whole product line of products at different sizes that are going to have those exact numbers. So, so this is something that the energy advisors need to realize. Secondly, I think there's a tendency for people to look at solar heat gain as cheap heat, free heat. Man, if I can just maximize the solar heat gain, I'm going to make this model work. But you have to be aware that there are comfort implications with that. When you have windows facing south, and if most of the windows are facing south and you say, great, I'm getting all this solar heat gain, you may have a home that is going to be highly unpleasant to live in because much of the year you're going to be way too hot in that home. And the more highly insulated the home becomes, as we're going with more highly insulated enclosures under the STEP code, the solar heat gain, you need less and less solar heat gain to be comfortable in that home. You start having a high solar heat gain window, and the people will be unhappy living there. They're going to be too hot. They're going to be, if they have a heat pump, they'll be putting it in cooling mode, or they'll want to get an air conditioner. They will not be happy. So solar heat gain can be beneficial, but too much solar heat gain is a real problem. And the problem of asking for solar heat gain that is simply not available because it's constrained by U value or the size of the product, that's a real problem. That's basically the specifiers choosing the products are not sufficiently informed. You have to look at what specific manufacturers can give you, what's available in terms of solar heat gain for the U values you want, and then you have to work with those numbers. The other important thing is that it's important when you're using HOT 2000, you can't use the legacy options to do this kind of modeling. You have to use the option that allows you to put in the CSA or NFRC U factor and the frame height, and then let the program calculate the actual characteristics of the window. I don't know why they still allow the legacy inputs to exist in HOT 2000, because they're not appropriate for use in building energy modeling for things like the STEP code. So you can't get any combination of solar heat gain and U value that you want. Solar heat gain is often undesirable, and the window manufacturers will tell you. Some of them are very frustrated when they're being asked to supply windows that they know the homeowner will not be happy with, because they know from experience that will lead to overheating discomfort. And you're putting the window manufacturer into a difficult place, to get your order. You're asking them to supply a window that's going to leave them with a customer that'll be complaining afterwards. So you really need to work with your window suppliers and discuss these questions so that you make better choices with respect to solar heat gain and U value. Did I miss anything, Safer?
No, I think that was a very comprehensive answer. And then on that design note, I know NRCan has a database for Energy Star products. Is there a similar product or a similar database where I can go and look up and see if I'm looking at U values in a certain range, what kind of solar heat gain coefficients am I possibly able to get? Or is it on a base, manufacturer by manufacturer basis that I should just browse catalogs?
Unfortunately, you're stuck with on the manufacturer basis. The Energy Star database, it would actually, for this purpose, it would be nice if it would be possible to look up the old Energy Star products that have expired, because it might help people to get a handle on the realistic solar heat gain characteristics of windows that no longer comply with Energy Star but do comply with code. So yeah, there is no place you can look these things up easily. The reality is that window manufacturers can buy glass from different suppliers. Although in the Lower Mainland, there's a couple of suppliers, there's a couple of glass products that are probably appear on most of the windows sold here. And I don't want to name specific manufacturers or companies, but once you look at what manufacturers are offering you, you might find that many of them are using glass products from the same company, and those product lines, you're likely to find very similar characteristics from the windows of all manufacturers that use those specific glass products. But there's no objective place you can look this stuff up, unfortunately. And it's partly also because the solar heat gain coefficient in the NFRC and CSA system includes the frame. It's not just a glass property. And so some window systems have a higher glass to frame ratio. If the window frames are wider, then you're going to have less solar heat gain. If the window frames are narrower, you will have more solar heat gain. So the numbers vary on the basis of the glass coating, but also of the frame width and also the product type, because they're evaluated at standard sizes. And all of those things make it impossible to come up with a single solar heat gain number that every window will have the same number.
I see. Thank you. There's a question about 9.7.4 and whether that's applicable to products that are required to have a fire protection rating.
Yes, and yes, I think I might have failed to read that sentence in 974. Correct. Products that are required to have a fire protection rating are exempted from the NAF's standard requirements. However, I don't know of any residential window or door product that would have a fire penetration resistance rating. So I don't know that it actually is something that you would encounter in Part 9 buildings.
Okay. And then there's a question about Passive House certified windows and whether they also by default require the PC building code requirements. And I also wanted to kind of use that to ask you a question again, kind of out of the original scope, as to the market trends and the cost of high performance windows, and whether you see a trend where these high performance products are becoming, more readily available at comparable costs to, code minimum or, what we have been traditionally using just to satisfy code minimum requirements.
So 2 questions there. Let's treat them separately. Passive House certified windows. Passive House certified windows are a bit of a problem here. A certified Passive House window, the certification is really certifying the window frame. It means the window frame has thermal properties that are acceptable for a certain level of performance in the Passive House world for a certain climate zone. And that's for a climate zone of Central Europe. And that's about the same kind of climate as we have in the Lower Mainland here. But it's certifying the frame system, not the glass in it. So it doesn't really tell you what the U factor is of a particular Passive House window in a building. If you're using a certified framing system, it has glass in it. The glass, whatever glass the window supplier is supplying, when you put that glass into the window, what's the overall U value of that window? We don't know what that is. In theory, you could have a Passive House window frame with a clear glass in it, right? And it would be a certified Passive House window frame, but it wouldn't have the same U value as if you had energy efficient glass in it. So passive house windows don't come with labels the way North American windows do. If the building in question is a certified passive house, so if there's a passive house certifier involved in the design and construction of the building, then the passive house certifier is ensuring that the windows and doors used on that building have adequate values to comply with the passive house requirement. And that's a level of performance that would be equivalent to step 5 of the building code. So if it's a certified passive house building, the certifier is looking after the windows, I would say. You don't have to worry about them. If it is just a builder who is offering you an imported European product that is claimed to have passive house certified framing system, it doesn't really tell you what the U value of that product is in Canada. And it may very well be a good product, but you don't know what glass option is in it. And without knowing that, and without doing the actual simulations, you don't have a number. So you can't just trust the fact, well, they tell me that I'm getting a certified passive house framing system, so this window should be code compliant. Well, it probably is, but they're not able to prove it. And under the code, you need to be able to demonstrate what level of performance you are selling. And there is a concern that a lot of imported product is being used here in Canada now. In some cases, the imported product is very well priced, economically priced, but it doesn't come with any performance metrics. Neither the structural air water ratings are not available. Typically, the energy performance ratings aren't available. If there's safety glass, there are no safety glass markings. If they're insulating glass, we don't know that they comply with the insulating glass requirements of the building code. So imported products are coming in with no evidence, usually of no evidence of compliance with the code, which is a problem. And if you just accept them because they're imported, then you have a playing field that is not level. Are you going to accept a manufacturer who forgot to put labels on their product and drives up in their truck and says, here's the labels, here's the labels. And then, or if you're going to say no to him, are you going to say okay to the one who says, well, these are great European windows, oh, show me the, how do we know it complies with code? Trust me, it complies with code. Well, maybe it does, but, it's not, I think people who import products into Canada need to take the steps to qualify those products in Canada so that building officials can recognize whether they meet the compliance requirements of the code or not. That's just my opinion, but otherwise there's no, the only other way to find out is to hire an engineering firm, and I know I was involved in a number of times in these kinds of situations where European product is installed and how do we qualify the safety glass? How do we demonstrate that it complies with the energy values of the code? It cost people a lot of money to hire engineers to do all kinds of analysis and things like that. And even then, sometimes we couldn't find a complete chain of documentation to verify that the glass actually complied with Canadian safety glass requirements or, it's a challenge. I know we're in a free trade environment, but we also have, a building code and standards and regulations, and those apply to products from anywhere in the world. The people who import them need to take the steps to find a way to qualify them so that they can sell them and demonstrate that their products do comply with the code in Canada.
Thank you. Al, I know we're almost at time, but I wanted to mention two more questions before we let you go, if you don't mind.
No problem.
One is about the air leakage rating that is reported on the energy performance label. And the question is how that corresponds to the air resistance metric on the structural air water label.
Okay. So the resistance on the structural air water label is the relevant one. When it comes to the NAF standard, the structural air water testing, those ratings are tested at the sizes that the manufacturer sells, or even larger sizes. The energy performance ratings are determined on the basis of a standard size. So the manufacturer might have a range of windows that all have slightly different air leakage or water leakage numbers. Only one of those air leakage numbers will be used on the energy performance rating label when they're calculating the energy rating. So, so not all energy performance labels report air leakage per se, I don't think, but because air leakage is not always a property, like under NFRC labels, I'm not sure if the air leakage is reported. But as I say, if it's on the energy performance label, great. But the one you're looking for under the Part 9 of the code is the air leakage level of the NAFS label, not the air leakage level of the energy performance label.
Thank you. And then finally, the last question. What does the condensation resistance signify, and how important is that in our climate?
The condensation resistance ratings today are not very helpful. You can't, if you're comparing two products, let's say, then if you have the for example, if you're comparing two NFRC products and one has a higher condensation resistance number, one has lower one, you know that the higher one is better. It has more condensation resistance than the lower one. But that's about all you know. You don't know, you can't predict whether it's going to lead to condensation in your house or not. There's a Canadian condensation resistance metric, but it requires physical testing, and so it's not used very much. So I would say the condensation resistance ratings are not very useful, and they're not a code-regulated property. At this point, our U values in the code are quite low, and so there's a heat transfer property in the building code. In Part 9 and in Part 5, they talk about heat transfer. And the heat transfer property was mainly related to trying to minimize condensation. And so as far as windows are concerned, heat transfer property would be satisfied if a metal window frame had a thermal break. The energy performance level of windows today is much better than just a thermal break in a metal window. So windows that comply with the U value requirements have sufficient condensation resistance under the code.
All right. Well, thank you very much again, Al. This was really interesting. I learned a lot. I'm sure all the participants really learned a lot from this presentation. So I just wanted to thank you again for your time.
You're very welcome. Thank you all.